Perimeter of shaded region. Perimeter of shaded region. Before finding out this perimeter of the shaded region, you must know that which lines are surrounding this shaded region. Okay? You can see that these 4 arcs are surrounding this shaded region, and these 4 straight lines, small straight lines, are also surrounding this shaded region. What is the length of each short line? 3. How? Because this total is 10. This radius is 3.5. This is also 3.5. 3.5 and 3.5 makes 7. Out of 10, you are subtracting 7. So remaining is 3 centimeter. So this line is 3 centimeter. This is also 3. This is also 3. This is also 3. Okay? To find out perimeter, you will have to see that 4 quarter arcs are making 1 full circle. 4 quarter arcs making 1 full circle plus these 4 small straight line. So this is 2 pi r plus 4 times of 3, because they are 4 small lines. 2 into 22 over 7, and the radius is 3.5 plus 12. Final answer? 34 centimeter. In this question number 10, you can see that the radius of the circle is 14. The radius is given. The radius of the circle is 14. Find the angle at the center of the circle subtended by an arc of length 12 meter, etc., etc. So here you can see that the radius of the circle is 14. You will have to see that the radius is given, which is 14 meter. This is the length of arc, because A, B, C, D, in these parts the length of arc is given, and he is asking you to find out the angle subtended by the radius. Angle at the center of the circle. Okay. So what we are going to do, we have to draw the figure like this. Here I am going to draw the figure. There is this circle with center O, AB. Say this AB is the length of arc. Okay. Angle in between, angle at the center, say it is theta. I am taking theta as the angle at the center, because he is saying find the angle at the center of the circle subtended by an arc of length. The arc of length, the arc length is given. The arc length is 12 meter. This is arc length 12 meter. Okay. Arc length is given. We have to find out this angle. The radius is already given, which is 14 meter. 14 meter. So you have already done in question number 9 also. Okay. What you are going to do, which formula should be applied? Okay. So arc length, basically here the arc length is given. So we have to use the formula for arc length of the circle, which is theta over 360 into 2 pi r is equal to the arc length, which is 12. 12 meter is the arc length. Now I am applying the values. Theta, which is required to be found, into 2 into the pi, 3.142, and the radius, which is 14. Okay. You can also use the value of pi as 22 over 7, because here you can see that 7 and 14 are cancelling each other. That's why I am using 22 over 7 instead of 3.142. 7s are 7, 2s are 14. In the next step, theta is equal to 49.1, 49.1 degree. This is the answer for angle subtended by the arc of the circle. Clear? Yes. Actually, this is the question. A piece of wire 32 centimeter long is bent to form a sector of a circle of radius 6 centimeter. Now this is a piece of wire. Actually, that piece of wire which may be straight, but after making its construction, what type of situation is occurring? Actually, this is a sector of a circle. You know that what is the shape of the sector of the circle? It must be clear to you. it is something like this. This is the sector of the circle. The whole wire starting from, if I am starting from O, this radius, this length of arc and this radius. It means two radii are included in this length and this arc is also included. Yes. So here you got this, that actually that length of wire has been bent to form this complete sector. In this sector, these two radii are also making the part of that sector perimeter. So we have this 32 is the total. Out of 32, this radius is given 6, this is 6, this is 6. So arc length, if I am saying that AB is the arc length, then AB arc is equal to 32 minus 12. It is 20 centimeter. Because why 12? Why I subtracted 12? 2 times of radii is subtracted. Clear? 2 times of radii is subtracted. Now I can apply the formula for the arc length. Theta over 360. We have to find out the angle subtended. I am taking angle as theta. So the same formula, theta over 360 into 2 pi r is equal to arc length, which is calculated now. This is the arc length. I calculated. Now you. G. How much is theta? 191. Is it correct answer? Okay. 191 degree. Question number 13. This is question number 13. You can see that find the radius of each of the following circles. Here I am going to solve part A. We have to find out the radius. In the previous questions, we were finding out the angle and radius was given. But here in this case, angle is given and we have to find out the radius. Yes. Length of arc is also given. Well, here you can see which formula will be applied. You can see that perimeter of the minor sector is given. Again, the same concept you have to apply. Whatever I applied in the previous question, the perimeter of the minor sector is given. Perimeter of sector. Because in this sector, you will have to see that which lines are included. In the perimeter of sector, you will have to identify the lines. 2 radii are included and this length of arc is included. This blue length of arc and blue radii. R plus R mean 2R, okay? Perimeter. This blue lines, you will have to see only these blue lines which are making the perimeter of the sector. 2 times R plus arc AB. Plus arc AB. Okay? So, the perimeter of sector is already given, which is 77.91. 77.91 is equal to 2R plus arc length. The formula of arc length, this is showing arc AB, this minor arc. Theta over 360 into 2 pi r. Here theta is 148. 148 over 360 into 2 into pi into r. Here you have to solve this equation and then make r as the subject of the formula. 4.58. Now 4.58 divided. 17. Yes. So r is equal to 77.91 divided by 4.58. So what is the final answer? 17 centimeters. So this is the radius. Clear?